So just that whole browser.
Okay, so.
Shows stuff.
Okay, where did it, I heard in something, I mean, like, just about where we were at.
I thought he was-
I'll draw it out. There's one point you did hear
Yeah,
about
and
and
Android
Android Brooks, we process, they all want that. I mean, how hard would that be?
Not hard.
Okay.
Sharon, how's your day?
Today, you know much about
Good.
that, or?
I just had-
Okay.
Yeah, send her that picture.
Yeah.
Feels like you're talking about.
Yeah, I'll draw a little.
Yeah, they were very this morning. Not to be perfect.
Okay, thank you.
It's been so long, been a long time.
Using the power presenter for this. No. I got there's some links. That's what? Links. I don't have to click. Okay. So you good with it? Yeah. Okay. Cool.
Any idea?
Was there any sort of for what intro or anything? Start when you're ready. But just so you know, this is the camera right here. So for them to see you.
You gotta have.
No.
I know that was. Yeah. Yeah. I would have been. Presented.
Yeah.
I don't know.
That's fine. Yeah.
Oh, wait, are we now?
Not the right one.
Okay.
That's next doors.
Sorry, buddy.
Sorry about that. I was working on an agenda. So, hi, how are you all doing? Well, thank you for coming out for this. I appreciate it. I'm going to talk a little bit about tidy data, which is a way of holding data, storing data that is optimized for analysis rather than for internal consistency or presentation, right? Which is what most people are holding data for. So I'll go through and I'll explain what all that means and where where this idea comes from and how it's changed how I work, and hopefully will spur a culture of sharing and replicability in data on campus. So yeah, go ahead. And one more, zoom in. You know, you can't give a talk anymore these days without an XKCD comment to start off. So this is mine. I don't know if you know XKCD, but this is absolutely true. Part of what I'm going to do is I'm going to show you something that is, Karen, can you, someone's trying to get in. You may have gone. Okay. All right. So I set up, so this is the talk that's sort of building on a talk that I gave a couple of years ago in 2019 at the NCHC, the National Collegiate Honors Council. And one of the challenges we had, I set for myself, was we have this data set called the ARC data set, admissions, retention, and completion. And so the question was, can I calculate everything I need to know for that data set to report to the NCHC using only Google Sheets, right? Nothing else. And that's what this is a reference to. It's absolutely bonkers to do this entirely in Google Sheets or in Excel, but it can be done. And so once you sort of see how it can be done in a visual place like that, it's easier to do it in non-visual ways because you can imagine it better. So we're going to walk through it. It certainly can do semester by semester calculations in Excel just fine. It's going to the retention and completion part that Excel really starts to barf on. And yes, it is a huge mess, a labyrinth of regex, replace, and rate formulas, but I have them all for you to show you how they work. So go ahead. So in any sort of data science issue, we have to talk about data origination, where it comes from, whether it's authoritative and whatnot. Data origination for us is web focused. That's where all of my materials come from. Go ahead. In this case, actually, one more. We don't have, I'm using fake data. So I created all of this data based on sort of the regular statistics of my population. So you're going to see names, you're going to see IDs, they're all entirely fake. It's not like I went in and took real data and replaced people's names. I went in, I said, generate me 100 students who have GPA distribution like my student GPA. So it's entirely fake, there's nothing to worry about. There's no student data in this. So the goal here is, as I said, our goal is analysis, not necessarily presentation or what the SQL data sets are set to be, which is internal consistency. We're looking for something that we can get quick analysis on. And these are sort of the outcomes that we can get to with tidy data. So if you can click on that first one, this is a map of current students in honors by zip code, first by state, and then see where it says 1 of 3. Click on that, so we go to 2 of 3, upper left. There you go. And then you might have to zoom in a little bit. It'll load. Oh, maybe it won't. Try 3 of 3. Oh, there we go. Yeah, no, there it is. Keep zooming in. There. No, it should just be the mouse, I think. Yeah. And so you can see it outlines zip codes, and the color of the zip code reflects the number of people from that zip code. So this is all based on a simple tidy data set that I import into Google Data Studio, and voila, here it is. It really is very simple. It's just a matter of getting your data into the right format. Okay, if you can switch back to the Prezi and then click on the next link. The dashboard. Same thing. This is all of the data you see on this fed by a single Google Sheet document. Right. And it does take minutes. It refreshes every 15 minutes. It's real-time data. You can see it by semester, total population, by class, by major. See the little, by college. You scroll back down a little. See the middle, the drop down where it says semester. Click on that. And then just hover over like one of the 08s and click only. Yeah. So you can, in real time, look at only a single semester or compare 2 semesters. Right now, those of you who've seen EAB, Academic Performance Solutions, it does all this, right? So you don't have to build a Google Data Studio to do it, but this was before we had APS, and it can be done again entirely from a single Google Sheet. Okay, back to and then hit the trends. The hard part in this, it's not that hard. It's just a matter of computational power. Is doing semester to semester over time comparison. like retention is inherently a temporal property, right? Retention is retained for a year, right? So there's an inherent temporal property there. It's not a snapshot. And so calculating that stuff can put quite a load on your machine. But so this is one that's all the temporal properties. And you can see same sort of thing. We can do all sorts of lovely graphs based on a single sheet. This is total population. This is starting population. Click to the next 1.5. Yep. And demographics, ethnicity, gender, both in starting population and total population. Next. Majors. And this is, again, it's dynamic and it's cool. If you click on one of in this chart, click on one of those, yeah. And it should adjust that. It may not. You can do the same thing with the drop down. So this is for students that were the first, that started in that semester, and this is the total population down here. But it'll show you the top 10 majors for that semester, or for all the time. Okay, and then 4 or 5. Full population and majors, and this one, yeah, try. This is like probation, right? So if you're over the limit or under the limit, click on one of those. Yeah. No, it's not working. All right, it may just be on the Mac, but that's okay. If you click, sometimes when you click on that, it'll show you the people in probation only for that semester. So that's full-time. Yeah, this is full-time, part-time, and this is on probation or not. And then click on 505. Minimum GPA on this one, above and over, above the limit and under the limit. So yeah, the idea is you can get all of this really lovely presentation data out of tidy data sets very quickly and relatively easily. I mean, there are some tricks to using Google Data Studio, just like there is anything, but the format allows for very quick analysis, and that's what it's supposed to be. So go ahead, go back to the Prezi, and yeah, next. So the goal, right? The goal of tidy data sets is replication, transparency, and sharing. Transparency is more about metadata and lineage, and I'll talk about that in a second. But it's about being able to share data sets in a consistent format that will allow different individuals to reproduce the same results, right? Get the same analysis. The tidy data sets are optimized for analysis and replication. They're not optimized for necessarily for presentation or for internal consistency, but it's easy enough to fix it. Okay, go ahead. So yeah, next. So I have some samples. You either can use that Bitly, or you can, if you have a phone, you can scan the QR code. I'll send over here. And that will open a Google Drive that is got all of these things in it, both in Google Sheets format and in Excel format. The formulas are going to be different because the languages are different between those two, but they ultimately do the same thing. All of the screenshots that are in, or all of the sheets that are in there. And so again, in honors, I'm looking for, go ahead. In honors, I'm looking for, I have two sets of things I'm looking for. One is semester comparisons, and the other are temporal properties like retention that are over semesters. So obviously, this is unique to us. This is our ARC data set. These are things that I have to report on to the national organization. I'm sure that any of you in different programs will have a different set of things to report on. Some of them will be common, like total population, starting cohort, gender, and ethnicity, and that kind of thing. Go ahead and go. And then we break by FIDIAC and transfer for honors. And that's an important distinction. And so all of the incoming metrics that are part of it. And then the between semesters, oh, you're right, and probation. Go ahead, one more. And then the between the temporal properties of retention and completion that are harder to calculate. Still involved. Go ahead. Yep, and completion and graduation. Okay, so the details. What is a tidy set? This is what I'm going to run through. So we're going to go through some basic things about code books, making sure that you document where things come from. and then how we manage data in this environment. And then I'll get you some of the more gritty details of data set, tidy data sets, but it's not that gritty, honestly. It's just a little different for any of you who are used to working with data sets in other formats. Okay, so problems with Excel, or how not to Excel, right? So these are some files that I inherited when I came to Ferris, and so I want to use them. And some of them I created, right? So I'm not criticizing others before I knew about tidy data. I used some of these bad habits as well. So some of the things that are sort of wrong with the way that people use Excel and commonly make mistakes. So in this one, this looks perfectly reasonable, right? First name, last name. What are those? One is yes, one is no. What is that yes or no to, first of all? And second of all, why when something is no, is there just a blank under yes? Couldn't you have in this column a yes or a no in a single column, right? So there's a variable, the values of which are yes and no, and it's not in a single column, in two columns, which cause all sorts of problems. And second, we don't have any idea what this date is, right? So if I come in as a new director and I open this file, I don't know what yes and no means, I don't know what the date means. But one more. Right, so the first thing is the value, if you have a variable that has multiple values, the variable should be a column, not the values, the variable, right? So the values go in the column, but the whole column should be a variable. So this is a single variable split over two columns. That is a date that's unlabeled. We don't know what it refers to, where it comes from, what it means. Go ahead. These two, we have sheets here, right? Excel language, these tabs refer to sheets. Sometimes Google Sheets, we call them tabs, right? Very confusing. Are those two mutually exclusive, right? Can a person be an upperclassman and off-campus? Why do we have separate sheets for this possible variable? Go ahead. Yep, one more. There's more. Using colors instead of variables. Again, go ahead. Right? So why are these people highlighted? Why are in red? Why? What does that mean? I'm coming into a new position. I open an Excel spreadsheet. I have no idea what red means. We're using, again, tabs instead of variables. On campus versus off. That's a variable that has two values, one on, one off. Easily be a column. Where does the student live? On, off. Right? Keep going. So color instead of a variable, tabs instead of a variable. Go ahead. Single variable in two columns. First year, start, transfer, right? We have different formats between the two, but these two are mutually exclusive. If someone is a first year, they're not a transfer. If someone's a transfer, they're not a first year. It can be in a single column. Go ahead. And yeah, tabs. One more. Right. Yep, same thing. Two columns instead of one, and things stored in sheets, not in columns. Go ahead. Yeah, and what is this? Right, it's just called sheet one. What does it mean? Why are these students on a separate sheet? What do they have in common that they're here? I have no idea coming in and picking up this document. And then sheet two is even worse, right? It's got all the same things. Go ahead. 465 people on this. I have no idea why they're on this sheet and not on the other sheet. Go ahead. If you want more, these are entertaining. This is an actual article about how to use Excel well, but this is a hilarious site of Excel horror stories, right? It's in the EU, and they post, examples of Excel fails that actually like crippled the NHS in Britain for 24 hours. Go ahead. So, first step in creating reproducible data that someone else can come in and pick up, is codebooks, right? Codebooks are documents that explain what all your variables are, what all your columns are doing, where your data comes from, all of those kinds of things, right? So it's metadata about your data. Metadata is, I'm a philosopher, I get to say weird things. One of them is metadata is a love note to yourself in the future, right? If you leave yourself notes, if you document where you got stuff, you will appreciate it sometime down the road. It always takes longer to write the metadata down. You always appreciate it. So if you think of your future self, right? This is metadata is leaving yourself the material that you need. Now, in reality, what I'm talking about today mostly is leaving it for the next person on, right? The next person who's coming into this position is going to look at this data. They need to know where it came from, what changes you made to it, right? That's all in, and what the different sheets and columns mean, that's all in the code book. So how, and then of course, definitions, if you want to get into some of the, like I said, this is based on the NCH data set, so I'm using what I need to know already, I'm borrowing from them. But if you're doing another, and you need to know, like, retention is a classic example. Retention defined by iPads is a calendar-based concept, right? So student who is enrolled one fall is enrolled again 1 year later. So a student who goes for fall semester, takes spring off, and then comes back is considered retained for the definition of retention by iPads, right? But that student won't have a full year of classes and will still be designated as the first year in their second year. So it's not quite what we often want to know. What we want to know is how many credit hours did that person earn in a year. So I could judge retention by looking, does the person have 30 credit hours after 1 year? That's not what iPads means by retention, right? So some of these definitions get a little squirrely, and it's good to keep that kind of notion down. So these are the ones that, for honors at least, are problematic and need further explanation. What does it mean to be current? What does it mean to be in good standing or making adequate progress? What does it mean to finish, right? You can withdraw, you can dismiss, you can graduate. We have different levels of completion of graduating at the associates and bachelors. We have people who complete the program but don't take a degree until later, right? All of these things we have to consider when putting this together. Database design, this is another one of those weird things that authors say, well, I said, database design is metaphysics. It's deciding what kinds of things in the world exist and what kinds of properties those things have. That's metaphysics, right? If you saw in my charts, you know, I have 4 genders in this data set. I could have more, I could have less. Deciding how many genders a person can have goes into database design, right? Banner tells us how many genders a person can have. Is the gender of a person something that happens at a time, or is it for the person all the time? Those are different in database. Semester by semester, if I track gender semester by semester, someone can change their gender. If I think that gender attaches to the root record of a person's ID, they can't change it. Right? And all of that is a part of database design and how you design your data sheets. Goal is replication of analysis, the origin of your data. Store your data as close to raw as possible. Right? Sometimes you have to make edits to your data, but you try to make those edits not to the raw data files that you pull out of Web Focus or whatever, but to how they're processed, right? So you can create a single Excel file and create another one where you do the processing for presentation and other things. All steps taken in cleaning the data, sorry, one back. All steps taken in cleaning the data are left somewhere so that someone can look at them, right? If you have to make changes to your data, if you have to combine first name and last name into a single column called name, you need to document how you did that, so that someone else who comes in can see what it is. And then a narrative analysis, including dead ends and negative results, like save future people time, because you might look, oh, does this correlate with that? And found no, it doesn't, right? Someone else is going to come in and have the same question. Would like to know, you know, it can save them time if they don't have to go down that road. And then for any symbols, factors, column names, abbreviations that you use, those all have to be in Codebooks. You can't assume that the next person is going to use the same thing that you did. So this concept of tidy data comes from a guy named Hadley Wickham. And Hadley is sort of a legend in the R world. He's one of the main people behind the resurgence of R in the last 10 years. You can use his concept outside of R, certainly. He's, if you're having experience with pivot tables, tidy data is related to pivot tables. You can use pivot tables on tidy data very easily, but I'm not going to probably have time to get into any of that. So it's, you know, this notion of pivot tables that came out is kind of like the Microsoftization of these original ideas of tidy data. But the point is that it's optimized for analysis. And of course, what this is always true, that data science is 80% collecting and cleaning data, very little actual analyzing or doing statistical analysis. I joke around that I like big data because when you have all the data, you don't do statistics. Right? Statistics is only for when you're extrapolating from a small population to a large population. If you have the entire population in your data set, statistics are useless. And it's all then just analysis. SQL, which is what drives relational databases like Banner and many others that you may have learned at some point, is optimized for internal consistency, not for analysis. Like I grew up with SQL, and it took me a little while to get used to typing. It feels dirty. I don't know. It feels wrong at first, and then when you start to see how powerful it is, it becomes very natural. For those of you who know relational databases, tidy data is not normalized, and for people in database world, that's like sin, right? I mean, it's just wrong. This is normal form is like achieving nirvana, and so to not want that is something that's just sort of wrong for database people. Go ahead. And again, the goal is replicatability. Okay. By the way, I always say that replicatability with a T, but apparently it doesn't have replicability. I have trouble saying that without the T in replicatability. But according to Google, replicatability is wrong and replicability is right. So in storing the data, thinking of the future self, right? Keep the data as close to raw as possible. Everything must be explained, column names and sheets explained, separate data from analysis. This is one that is that we'll get to, and then document. Okay. This is also, there's a famous paper, it's on the next slide, that Hadley wrote, introducing tidy data. And, starts out saying, like families, tidy data sets are all alike, but every messy data set is messy in its own way. Whenever, I was doing it this morning, I got this is part of what I was talking about, Andrew. Gen Ed assessment coordinator this year that I'm filling in for this year. And I saw in a presentation by Janine a couple of days ago that they do an exit survey, right? I know about the application for graduation. We're going to get some questions on there for Gen Ed assessment, but there's some technical issues. So she showed this exit graduation survey. The first question on the survey was, how satisfied are you that you can now, and the questions were like, be globally citizen, right? And things that are directly related to our Gen Ed. So I said, that's awesome. I can use that for Gen Ed assessment. Can you send me the data? And so I got the data, the raw data, and it's just a mess, right? I mean, it's from like SurveyMonkey or something. But so for each one of those questions, that's a Likert scale from totally dissatisfied to very satisfied. The values are in separate columns, right? So there's a column called very satisfied, and the people who responded to that have entries in that column, but the people who responded to other things have entries in the next column over and the next column over, right? So you could just we just need to take all four of those columns and like do that, because a single person can't answer twice on these. They can only answer once. I don't know why it's laid out that way, but that's the way it was laid out. So it takes me 3 or 4 hours to get it into a format that you can analyze, because that you can't analyze. And then, of course, this morning, Kristen sent me, that was 2020, 2021. She sent me the 2019, 2020, and it's totally laid out a different way. So I was hoping like, I could just throw that in the same folder and run the same script. No, I got to write an entirely new script, 2019. So each data file is messy in its own way, but we store them in a tidy way that we can do these things quickly. Now, this is my sort of asterisk, right? And that I'm doing this in R. Right? I'll show you things in Sheets and in Excel, but once I got it into my head how this stuff works, I'm doing this in ways that I don't see it. I do it in scripts. Right? So what I might say, it takes me just a couple of minutes, that's a little bit different than what it would be in Sheets. But I will show you in sheets how to do it as well. So the three principles of tidy data are these, and that's it. Each variable forms a column. Now you're going to say, well, what's a variable? And that's a very good question. A variable is anything that takes, see this, yeah, it's difficult. Hadley Wickham defines a variable as anything that takes value. That's not a great solution. Quine, W.V.O. Quine, philosopher of mid-century philosopher of science, one of the biggest names in the 1970s, said to be is to be the value of a variable. That phrase always bothered me because I never know what being the value of a variable is. So a variable is anything that can vary, right? I mean, I feel like we all understand the concept after algebra, but it's actually much more complicated and subtle than initially seems. There are obvious examples. Gender varies, ethnicity varies, right? But there are others where it's just not clear whether it's a variable or not. So the rule of thumb here is it's the rule of thumb on what columns you define are which are relevant to the analysis. So variables are ones that we're going to use in the analysis. I'll give you another direct example of the gen ed conversation. We're talking about collecting data from gen ed courses. Do we collect that at the individual student level, at the course section level, the course level? Right. So if I ask faculty to tell me how many of their students got a 4 on this rubric, do I want each student's response? You know, I give them a list of students and they say, this one got a 4, this one got a 3, this one got a 4. Do I say how many, you know, they say 35 students out of 40 got a 4? Or do they, you know, get it together with all the other people who teach that course, they do 2050 and respond, you know, 110 out of 250. That might seem relatively minor if it's aggregated all later, but it does go to how, you know, how much information we can pull out of that as an analysis. If I want to know if there is a discrepancy based on gender or ethnicity in our gen ed rating, I have to have the individual data, right? I have to have the level of students. If I only want to know courses compare from one semester to the next, I can take it as a course. If I want to know is one instructor not doing the survey right, I have to have it as a section. So the analysis determines what level we collect data at. The analysis determines what counts as a variable. The second is each observation forms a row. So an observation is an observation usually at the time. Right? So in what I'm going to show you, observations are student semesters. They're the observation of a student at a semester. Right? Fourth day count will work, right? It's that student was present on this day, snapshot. And then the third is each type of observational unit forms a table, right? So the table that I'm looking at has observations of student, student at a semester, right? And if I'm going to have students over time, like retention, I'm going to put that in a different table. Right? So student semesters in one table, students over time in a different table. Okay, go ahead. And that's tidy. So here's the actual paper called Tidy Data. I had the Wickham, and there's the link if you want to see it. Like families, Tidy Data, Betsy, or like, and Betsy are Betsy in its own way. Okay, so here's the example. Go ahead and click on the docs. And this one is entirely my fault. Right? I built this table and it's messy. So we first got here, I wanted to know what honors courses had been taught, what gen ed requirements they filled in. So I went out and I pulled the list. Here's the list of courses, right? And there's a web focus report that generates this for me now. If there's any prereqs, if they meet cultural, global, race, science, social, FSUS, communication, when it was last taught, whether it's regularly taught fall or spring. So, right? Yeah. So I, in my pre-tidy sense, I thought, well, look, these two are not mutually exclusive. So one can be both cultural and global. So I have separate variables here, right? And the same with fall and spring, can be taught both in fall and spring. So I want to have the F. So the question is like, what's the X? What does the X mean? the X means roughly like yes or true in this case, right? So the X is not meaningful unless you know what column it's in. So under here, click on tidy. So the tidying of this set is to put the gen ed variable into a single column instead of spread across 5 columns, right? So it has all the cultural, all the global, because that's what I'm going to want to know. I want to know how many global, how many cultural, right? So I put it all into a single column. What that does, of course, is if something has more than one, it's going to duplicate the number over here. And that's where the SQL people get screwed, right? Because the SQL people say it's got to have only one. You can't replicate data that's not normal form. And they're going to get full scroll. And then, but it's usually offered, those two can be collapsed as well. So you have both, and they collapse. And then click on help. So the reason why this works is now I can do this very quick analysis on gen ed, vol strength, and individual courses. Go ahead. Yeah, right there. So unique, the unique function in Google Sheets just was added to Microsoft Excel. For like 2 years, everyone in the world was complaining that Excel did not do it. They finally allowed it. So now you can use unique. Before you had to like copy and paste it to another sheet and use, it was messy. It took the mouse. So now you can do it via scripts. So unique, tidy, and GG, if you click on the tidy one, GG is the column that has the gen ed, right? So this gives me all the values. So the first thing that a SQL person is going to say is, wait, what if one person calls cultural CULT and the other person calls it cultural, right? You're going to not have a matchup. Well, when you do unique, it's going to show you all the values, all the distinct values. Then you can just go back and clean, right? So getting the data and getting it in the right format, tidying it sometimes is to go through and replace all of the typos of cultural with one single thing. It's very easy to do because you can see them all here. So then click on B2. And
Right
that's,
here?
yep.
Can I ask a quick question?
Yeah.
Unique is counting the number of times that uniquely happened in that category.
No, that's counted.
Oh, okay,
So unique is just
Just
the
the
list of
category.
unique entries in that column.
okay.
And then this count if, right, is count if that same column, the GG, is equal to 8, equal to column. Right? And so this, then down here is the sum total. So this is what I call like the base unit of analysis in tidy data sets, that sort of square, right? Unique and then calculus in that column. And you can do, percentages there too. And you can use that for any data that is set up in this tidy way. And that's how all of those spreadsheets, all of that dashboard is done. It's just done like this. One column that has multiple values, and it just calculates the percentage and the totals using this kind of simple calculation. Spring, summer, same exact thing, and you'll notice that the totals match. And then this is unique on the courses and the total in the courses. So that's an analysis based on the tidy set. And like I said, the tidy set is now sort of, we don't touch it, right? We can add things to it, but we don't do our analysis on that sheet. We do it on a different sheet. Right? So that the original data is as close to original as possible. So go ahead and click back on the present. Click next. And this is just screenshots of what I just showed you. Should be. Yep. Okay. Yeah. So this is the tidied way. This is the unit of analysis. You can see they're all just count ifs, and then a sum of them total, and that's what you get there. And then click on this. So all of that data that I showed you on the first one, the big dashboard, is all coming from this. This is my first one is the tallies. This is the analysis. Click on the S2006-08 here. So this is like a semester snapshot. This is a tidy data set of a semester snapshot. So each row is a single observation of a student, right? And the variables that we're interested in for analysis are going this way. And remember, totally fake data, not real data. No one here has that many, or that ID. It's all paid. Each row is a single observation at a student. The existence of that student in this table means they were present on campus in that semester. And they had these values for their various things. You scroll just a little bit so we can see the rest of the columns. Yeah, keep going. Initial term when they started, current semester, and that's the same, that's when Banner started, major, college, degree, on various other points. Click on one of the higher ones like 2009, 08. Yeah, that's fine. 808 is fine. What I wanted to show is slide over a little. Is that for these, the initial term and the semester are going to be different. One more. All right, so in this one, the initial term is when they started. The semester is the semester we're looking at. Right, so this student was present in 2008, 08. They started in 2006, 08. So we keep both of those data going throughout the title. And then go back to tables. So all of this is just that same square of analysis. Right? All of this is just unique for the column of gender. This is unique for the column of cohorts for starting semester. This is unique for degrees. This is the total count of unique items in under degree, right? This is unique for college. This is unique for ethnicity. And then these columns are all just count ifs. It's count that column if it's equal to this. Count that column if it's equal to that. And then of course, over here, this is just unique for all the cumulative GPAs. And that's just a histogram of all of that. So it's just the number of, I set the bin width in histogram, but the number of these that fit these bin widths. And then scroll down a little. And we have students who are on probation or under the limits of credit hours that we have. And it's the same thing. It's just that the unique is also filtered. Right? So it's the unique student IDs that are under this limit and then their name given that ID. And that's really it. Now the cool thing, the one sort of, go back up. Cool thing that I added to this and over to A1 is a drop down to make it dynamic, to change that. It doesn't matter, any one of them will do. And it should update to that value. So that part is cool. The rest of the analysis is just straightforwardly that simple unit of square of unique and count ifs. Only two scripts that you need to use to do all of this. Okay, switch back over. Oh, okay, I won't go too much further. I'll click next. Yeah, so you could say, right, but wait a second. I saw that you had tabs on the bottom and that those tabs represented semesters. Semester is a variable, right? And the values are the things that you have there. So you didn't make it a true tidy data set. Right, I didn't. I had them separated out because if you put them all together, that's a really easy way to crash a computer. Go ahead and click next. Yeah, there you go. This is what happened when I put them all together. There is a Google Sheet and an Excel file that is available for you in that document to look at, which I took all those semesters and put them in one huge table and then ran some same kinds of analysis on it. It works. That's my CPU percentage when it was working on it. 391% of my CPU was working on it. And this is the amount of memory it took while it was working on it. So I don't advise doing that, but it can be. So the separation of semesters, the violation of the laws of tidy data, separating them into individual semesters is my concession to, I'm not going to wait 8 hours for an analysis to complete and accept, right? Now that's where also, the asterisk from the beginning, once you get used to this, you can use tools like R that can do it in seconds. Right? And, but it is hard. There's a learning curve to get into the concept of tidy data because it's so weird. It just feels unnatural. Those of us come from equal and other backgrounds where Excel sheet, storage of the data is the very thing that you present to someone, right? The colors and highlights and things like that. This is saying, don't do that. Storage of the data should be raw format, in a tidy format. And when you present it, it should be a separate document, not stored. You know, that's your analysis, that's your presentation. It's not a part of the long-term storage. So yeah, that's it. That's tidy data sets. So, and do you have any questions or further?
I've got a quick question.
Yeah.
So you've obviously tidied all of the data, but then every semester, when you get the new raw data from the web focus, you have to re-put it into your.
Well, but ultimately, like, you know, once I started doing this, I changed my, I worked with web focus to create reports that are correct.
Okay.
Right. So my current report, I can just dump into a directory.
Okay.
And it's the same format as the other. But that's like, you know, the Gen Ed problem I was talking about this morning, that because I'm getting raw data in different forms, that takes some.
Right.
But the idea is saving that work for the future. If I store it in a tidy way, then, you know, when I come back in a couple of years, or when someone else, I do not intend to take that position, when some other Gen Ed coordinator comes along, Gen Ed assessment coordinator comes along, they can get that data and look at it. Do the analysis. Oh yeah, and this is just, you know, my complaint about Excel. This is the single greatest stack. Stack Overflow is where, you know, you can get help on programming. And I looked something up. How do I do this on Excel? The top voted question is this. Copy it to Google Sheets, do it there. Copy it back. So yeah. Other. That's fine. So yeah, the ultimate goal, as I said, is shareability, replicatability, transparency of the process. So for example, like that Gen Ed, this is awesome. So the process that I go through to clean the Gen Ed survey needs documentation. Right? That's the piece that could potentially vary. Right? If I leave and the person comes in doesn't know R, their process of cleaning it would be a little different from my process. But it should be documented in plain enough English that people understand, or the future person can understand, it took these 5 columns, right? And then stored it in that way so that I can. Anything in the chat? No chat change.
I think that was from the last one.
Oh, okay. Yeah. Right on.
Right on.
You can ask. I certainly.
Thanks, Peter.
You want to sign out of everything?
Yeah, sure.
We can just do this. Use Comic Light.
Which one?
You use Comic Light?
No.
Comics?
No, those are XKCD.
Oh, try Comic Light.
All right.
It's like it's only a Mac program,
Okay.
but it's what comic writers are using for all of their dialogue, because the dialogue and the dialogue levels are so great in it.
All right.
So anyway, I love it. I thought it was so fantastic.
Yeah.
Yeah.
You know, another thing I like too a lot is how-tos.
Yeah. You mentioned that before.
Yeah,
I took a look, but I haven't gotten to the green. Yeah.
Anyway, check.
Give anybody a brief from your.
No, I
Okay.
think we're all good. Russ is back, so from his event, so,
Okay.
Thank you.
yep. Thank you, Russ.
We're gonna go. This